Xception neural network is a deep convolutional neural network that improves upon Xception by using depthwise separable convolutions instead of standard convolutions. The architecture of Xception network is inspired by Xception v3 but completely factorizes convolutions into spatial and depthwise operations. The high-level architecture of Xception network comprises of three steps. The first one is entry flow, which extracts low-level features. The second one is middle flow, where deep feature learning with depthwise separable convolutions takes place. And the final one is exit flow, where final feature extractions is done and images are classified. In entry flow, we will have standard convolution layers with ReLU and batch normalization layers. Then we will have three main blocks, where the main blocks comprises of depthwise separable convolution layer, batch normalization layer, ReLU activation and max pooling layer. At last, in the entry flow, we will have residual connections. After that, in the middle flow, we will have 8 identical blocks, and each block comprises of 3 depthwise separable convolution layers and a skip connection, that is residual connection. In the middle flow, there won't be any downsampling. Here we only transform the features. And in the final step, that is exit flow, we will extract the final deep features before classification. Here also we will use depthwise separable convolution layers, and we will end with a global average pooling layer instead of fully connected layers. This is what the architecture of Xception network. So let's implement this using Tensorflow and Keras. So to implement this, we have to import Tensorflow and Keras. So let's run this cell. Yes, we have successfully imported Keras and Tensorflow. So in entry flow, we will have few layers: standard convolution layer, ReLU layer, that is activation layer, and normalization layer. So these are the few layers, that is convolution layer with 32 units and 3 filters and passing some inputs to it. Then a batch normalization layer and an activation layer with ReLU activation function. So few layers we have to keep this, therefore I am going with 2 times occurrence of these 3 layers. After that, saving the output in the previous block activation. Then we are going with the 3 main blocks, in which we will have 2 times depthwise separable convolution layer, batch normalization layer, and ReLU activation function. So here also you see we have activation function, then separable convolution layer, then wedge normalization layer. Again we have activation layer, separable convolution layer and wedge normalization layer. After that we are going with max pooling layer, and this max pooling layer reduces the spatial dimensions. Then residual connections. So residual connections are done here. After that we are adding both output of the max pooling layer and the residual connection layer and saving that in the variable x and passing the same to the previous block activation, and this loop iterates 3 times with different sizes like 128, 256, 728 units. This is the entry flow where we have to provide the input, and in the middle flow we are passing the output of the entry flow. So in middle flow we will have 8 identical blocks, therefore number of blocks is 8, and the output of entry flow is passed to middle flow through the parameter x. So previous block activation variable saves the output of entry flow. Then we are running the 8 blocks. So in each block we will have 3 layers of depthwise separable convolution layers, and with that we will have wedge normalization and activation layers. So these are the 3 layers. Then so we are adding both output of these 3 layers and adding the previous block activation, that is the output of entry flow, and saving that in the previous block activation, and doing this 8 times. After doing that we are returning the x. So here we are not downsampling, we are just transforming the features. And in the exit flow block we are passing the output of middle flow and saving that in this previous block activation. Here again we will have some depthwise convolution layers. So these are the 2 depthwise convolution layer, and then we will have a max pooling layer, and then we will have a residual connection and addition of residual with the output of this max pooling layer. After that again we will have 2 more depthwise separable convolution layers along with activation and wedge normalization layer. Then finally we will have a global average pooling layer and a dense layer for classification. Then to make a model of it we will use the functional API. So we will have an input layer of this SEP 128, 128, 1, and we are going with entry flow, middle flow and exit flow. Successfully we have created the Xception network. So this is the code, don't worry about this, I will upload it in my GitHub repository. So let's move to the project, and in this project I have not implemented whole Xception network, but I have implemented some portion of Xception network to do the classification. Hello friends, Welcome back for another deep learning projects image classifier where I am using an Xception neural network to classify pet images into cats and dogs classes. I am here using TPU runtime in Google Colab Notebook to train the model with more speed. So let's start. At first I am importing libraries like Tensorflow, Keras, NumPy, Matplotlib and OS. After that, as I am using TPU runtime, so I have to go with some TPU strategy. So the TPU strategy code is this, where we need to create a resolver. Then we have to write these lines of code. I am using TPU strategy and passing that resolver to this TPU strategy and saving that in the variable strategy. So this is the required code for using the TPU as a runtime. After that, I am downloading the cats and dogs dataset from this zip folder available in this link. So the data is downloading. Yes, it is successfully downloaded, and as it is a zip file, we have to unzip it using this line. I am unzipping the zip file, then I am seeing the folders available. So it's unzipping. We have pet images folder, readme1.txt file and sample data, and this is the zip file. So let's see the folders present inside the pet images. After that, I am filtering out corrupted images present in the folders cat and dog. So to filter out the corrupted images, I have written these codes. So at first I am choosing a folder between cat and dog, then I am getting the path of the folder, that is cat or dog. Then I am going to total number of images present in that folder and iterating over each image and saving that in the variable file name. And with this os.path.join, I am creating the path of the file and saving that in the file path, and opening the file path in the read binary mode and saving that in the file object. And if the first 10 elements or text of the file object contains jfif, then it is passing the case, and if not, I am deleting it. So this is to check the condition. After that, I am closing the file object. So we have a if case where if the file object is not following jfif code, then it is removed from the folder. So we have os.remove and the file path passed over here, then incrementing the total number of skipped. So let's see how many are deleted and how many are present after deleting. So filtering out, so we have deleted around 1590 images, as these are corrupted images. Then Then from these folders I am going to create a dataset, as all the deep learning models take their inputs as dataset, so we have to convert the image files to dataset. So I am resizing the images to the size 180, 180 and saving that image size in the variable image size. Then creating batches of 128 elements. Then using the image dataset from directory method and passing the required parameters, I am creating the two datasets. One is train.ds and another is test.ds, that is val.ds. So inside this method I have passed the folder name, then passed the validation split equal to 0.2, that means 20% of the data is reserved for validation, and passed subset equal to both, that means it will return train as well as validation. Then seed equal to 1337, it is a random seed number, which means every time when we go with this, the same dataset is returned by this method. Then changing the image sizes and giving a batch size, and this method will create batches where each batch contains 128 examples or elements, and each image becomes a size of 180, 180. So let's run it. So here you can see we have 23,410 files belonging to both the classes cat and dog. Then we have 18,728 files for training and 4,682 files for validation. After that I am going for visualization of the images. So I am taking a batch from the dataset train.ds and separating image and labels. After that, from that batch I am plotting only 9 images with their labels. So this is the code for plotting 9 images of a batch with their labels, and labels are converted to integer type. So let's run this. So here we are going to see the 9 images. So you can see these are the 9 images we got. After that I am doing data augmentation, so that whenever we have few or less number of data points or data files, we can generate few more data from the data files available with us, so that overfitting will not occur. So in augmentation layer I have two layers. One is random flip, where I have passed horizontal, that means files or images will be flipped to horizontal, and there is another layer random rotation with 0.1, so 10% randomly rotated. So these are the two augmentation layer I have. Then after that I have created a method data underscore augmentation, where I am passing images and iterating over all the augmentation layer and passing images to each layer and returning that images. So let's run this cell. So let's see the augmented images. I am taking the first batch, and from the first batch I am plotting the 9 images, augmented images of a single image, and showing that. Let's run this cell. The image is flipped horizontally and there is a random rotation of 0.1 proportion or 10%. You can see 9 images are produced by these layers. After that, I am applying the data augmentation to whole train DS and validation DS, and also I am setting auto tune to number of parallel calls, so that most of the or maximum numbers of processing units can be utilized. Then I am prefetching the train DS and validation DS again with the tf.data.autotune, so that before processing the s+1 epoch, we will fetch the s+1 data in s epoch. That's what the main reason for prefetching. Let's run it. Yes, so the data augmentation and prefetching is done. After that, I am going to create a small version of Xception network, and already I have explained about the Xception network, so I hope you will understand it, and it's not so hard. So I am creating a method model creator where I am passing two parameters, input sep and number of classes. Then I am creating a input layer, passing this input sep, and then I am rescaling. I have a rescaling layer, then convolution 2D layer, then a batch normalization layer, and a ReLU activation layer. And outputs of each layer is passed to the next layer, and final output is saved in the previous block activation variable. Then iterating about 3 sizes. As in the entry flow, we have 3 main blocks. Those are these 3 main blocks, the 256, 512 and 728. 3 main blocks, inside which we will have separable convolution layers with ReLU activation and batch normalization layers, and all these outputs are generated, and outputs of whole activation layer, separable convolution layer, batch normalization layer is passed to the next layer. After that, I am going with a max pooling layer, where the output of this last batch normalization layer is passed to it, and the features are extracted. After that, I am going for a residual connection, where I am passing the previous block activation. So for that residual connection, I am using convolution 2D layer and adding both the output of this max pooling layer and the residual. After that, I am saving that in the previous block activation, and I am doing this for 3 times with these 3 different sizes. After that, the output of that is given again to a separable convolution layer, then a batch normalization layer, then an activation with ReLU function, and finally, and this is the entry flow. I have skipped the middle flow, and in the exit flow I am doing a global average pooling, then creating a if else block so that I can have the number of units in the last classifying layer. So this is nothing but if the number of classes is 2, then units equal to 1, and else the units equal to number of classes in the last dense layer. After global average pooling, I am dropping out 25%, then passing the output of it to a dense layer and saving the output of it in the variable outputs. Then calling the model API, I am creating the model. So let's run this. Yes, model creator is executed successfully. Then as we are using TPU, that's why we have to build the model inside the TPU strategy. Therefore, under the strategy.scope, I have created the model and compiled the model. I am using Adam optimizer, binary cross entropy loss, and binary accuracy metrics. So let's execute this cell. So it is taking some time. Okay, it's done. And then I'm training the model. So to train the model, we have fit method, but in the fit method I have passed train ds, that is training dataset, and going with 25 epochs, and in the validation data I have passed validation ds, and in the callbacks I have created a model checkpoint callback. So the model checkpoint callback is nothing but whenever if the TPU is disconnected while training, the weights will be saved in this checkpoint file path or in this location, so that if we want to restart the training, we can use the saved weights and apply to the model and execute from there onwards. That's what the main purpose of this model checkpoint callback. So to create this, we have model checkpoint method in callbacks module of Keras, where we have to pass a file path. Then to save the weights, we have to pass true in the argument save weights only. Then we have to pass monitor equal to val accuracy. So to monitor validation accuracy, I am creating this, and mode equal to max. So validation accuracy should always rise, that's why I am creating this, and save best only equal to true. So best result will be saved if the training stops in interval. So let's run this cell. So the model is training. It will take some time. As we are using TPU, this may take less time than a GPU, and already I have executed this same project or model in CPU, GPU, and also TPU. In CPU, I found 2 hours to execute 2 epochs, and in GPU I found 1 hour to execute 10 epochs or something like 12 epochs, and in TPU I found 2 minutes or around 1.5 minutes to execute 1 epoch. So let's see how much time it will take. And don't worry about the time, I will increase the speed of the video for this purpose. So after 24 epochs, the validation accuracy is 93% and the validation loss is 17%. But you can see after 21 epochs we got validation accuracy is 96% and validation loss is 8%. So that is the highest validation accuracy we got. So in the last epoch, let's see what will be the validation accuracy and what will be the validation loss. One last. Okay, the model is successfully trained in 26 minutes and the validation accuracy is 88% and the validation loss is 27%. After that I am saving the model to use it in the inference. So let's save the model using save method and saving that in this file path model.keras. And for showing this to you peoples, I'm going with some inference on new data. So I'm randomly picking a pet image inside the cat folder and loading that image with load image utility present in Keras and changing the size of the image with this argument. After that I am showing the image with this method, then converting image to array and expanding the dimensions and saving that in the variable image array and using that image array to predict and saving the prediction of that image in the variable predictions, and it will return a two-dimensional array. That's why I'm finding out the value of the array with this prediction bracket 0 bracket 0 and applying the sigmoid function to this value and converting it to a float value and saving that in this core variable. So after that I'm printing the prediction, and as the dogs have the level 1 and cats have level 0, that's why I am doing 1 minus score for cat score and the original value is the dog score. So if the cat score is greater than score, that means it is a cat, and if score is greater than cat score, then this is a dog. And better, let's change it to dog score. So let's run this. Let's see the cat and what the prediction will be done by our model. So here, yes, we got this is the prediction value, and it is printing this is a cat. Wow. So yes, this is a cat. So with this we have completed the first part of this project, and let's build this second part. Let's start the second part of cats versus dog image classifier. Here we will create an user interface where the user can interact with the model, and using Streamlit library we will create this user interface. So let's begin. At first I have imported libraries like Streamlit, Tensorflow, Keras, NumPy and pyplot of matplotlib. Then I have loaded the model using the load model method and passed the file path model.keras and saved in the variable model. Then in the user interface, at first I have a title, and the title is created with two things inside a container. So the two things are two columns. One is for image column, the another one is for heading column. So to create a container we have a method st.container, and to create columns we have st.columns. So inside these columns, in image column I have passed an image with width 150 units. Then in heading column I have written image classifier with two images, one is a cat, another one is a dog, and also I have given a description that this is a deep learning model built with a small version of the Xception neural net for classifying pet images into cat and dog. Then I have created a classifier method which classifies the images provided to it. So in the method I am passing the path of the image or the image file. So when this path or image file is given, I am loading that image file or path to the variable image using this, and resizing the image to 180 cross 180 and showing that image using this method plt.imshow. After that, converting the image to array using image to array method of Keras library and saving that in image array. Then I am expanding the dimension in the axis 0 and saving in the same variable. Then using the predict method applied to the model, I am predicting the image and saving that in the prediction variable. And as it is a two-dimensional array, as the prediction returned by the model is a two-dimensional array, that's why I am taking out the value inside the two-dimensional array and applying a sigmoid function to it and converting it to float and saving that in score. So as the cat score equal to 1 minus score and dog score is simply the score. So after that I'm going with a if else block where if the cat score is greater than the score, that is the score of dog, then I am returning cat, else I am returning dog with these two images. So this is the classifier method which classifies the input images into cat and dog. Then I am creating container for input and output. So inside this container I have two columns, one to select the images provided and another to upload the images from the local disk or from the browser. So these two columns have different purposes. So in select call I have given some names of cats and dogs and 10 images are provided here. So if any option is selected, then that is stored in the selected image variable, and if it is selected, then I am creating a path and showing that image with this width size and passing that to the classifier method with this path parameter or argument. And inside upload call column I am creating a file uploader where you can upload only one file. That is why I have passed the argument accept multiple files equal to false. Then if file is uploaded or image is uploaded, then I'm showing the image with width of 230 and passing that image to the classifier method, and it will return whether it is a dog or cat. After that I have a container for sharing contents with the viewers, the users, the beautiful and handsome audience. So here I have YouTube call, Xception call, Medi call, repo call, LinkedIn call. These are 5 columns created using this columns method with varying width sizes and specified gap equal to small to have small gap between each call. Then inside each column I have either a link button like this or simply a button like this, and inside these buttons I have specified a label like video, hspace, medi, repo, connect. Then I have specified an icon to each link button or button. Then I have specified an URL to each link button, then specified a help argument for more information about the button. So in the YouTube link button you will be directed to the YouTube video which will have the explanation of how the model is created and how it is implemented. And in hspace column you can have the application and this Hugging Face space where you will find the application file and the application and the model interface. And in the Medi call it is disabled right now and it's a personal page of me and it will be enabled very soon. Then a repo call where you can find the materials like codes in the GitHub repository, and then finally a LinkedIn call for connecting with me in the LinkedIn. Let's run this application file. So to run this application file, open the terminal. So in VS Code, to open the terminal, press Ctrl plus tilt. we are in the required directory, so that is cat versus dog, and the directory is also cat versus dog. So to run this application file, we have to enter streamlit run app.py and then press enter. So here we are redirected to the Brave browser, which is the default browser in my laptop. So the application file is running. Let's wait for some time. I have used the Xception neural network. Please try this and implement as I have implemented. So here we got the image classifier. This is a deep learning model built with a small version of the Xception neural net for classifying images into cat and dog. So you can see this is a cat and the output is shown cat. Let's change it to some other images. So see, it is showing cat. So let's change to dog. It is showing dog. Let's change to cat 5. Yes, it is showing cat. Let's change to dog 4. Yes, it is showing dog. Let's change to cat 4. It is showing cat. Let's change to dog 5. It is showing dog. Let's upload some files from the browser. So let's go for some dogs images. So let's go for this image. Let's drag it and drop here. Image is uploaded. See, it is showing dog. Let's go with another image. Let's go with cat's image. Let's go with this image. You can show it is showing cat. You also can see other images. So let's go for this image. It is showing cat. Let's go for a dog image. Let's select one dog. Just scroll down. This dog, or let this be the dog. Let this be the dog. Drop here. So see here, it is showing dog. So it is done. So you can see the image classifier is classifying correctly and accurately. You can use this in your projects. Thank you for listening me patiently. Have a good day, my dear friends. Thank you. Be successful in your life.